Understanding helicopter fuel systems. An introduction. A helicopter's fuel system stores and delivers fuel to the engine. It must operate reliably under all flight conditions. Think of it as the lifeline of the aircraft. Pilots need a thorough understanding of its workings. Any malfunction can have serious consequences. Knowledge of its design and operation is paramount for safety. Fuel storage. The vital role of the fuel tank. The fuel tank is the primary component responsible for storing the helicopter's fuel supply. Tanks are designed to hold a specific quantity of fuel, which dictates the aircraft's range and endurance. They are typically located within the airframe in areas that offer some protection. Modern helicopters increasingly utilize bladder-type tanks or crash-resistant fuel systems. These advanced designs are made from flexible, puncture-resistant materials to enhance safety. The internal design of a fuel tank often includes features to manage fuel movement. Baffles are commonly installed within the tank to reduce the sloshing of fuel during flight maneuvers. The overall shape and construction of the tank are carefully engineered to fit the available space and meet stringent safety standards. Regular inspection of fuel tanks is an important part of helicopter maintenance. Proper care and attention to the fuel storage system contribute directly to the overall safety and airworthiness of the helicopter. Essential tank ancillaries, vents, drains, and overflows. Every fuel tank requires a vent system to function correctly and safely. The primary purpose of the fuel tank vent is to equalize pressure. Without a vent, a vacuum would form inside the tank, which could restrict fuel flow or even cause the tank to collapse. Conversely, as ambient temperature increases or during refueling, fuel volume can expand. The vent allows this excess pressure to escape, preventing overpressurization of the tank. Another crucial feature associated with fuel tanks is the overflow drain. The overflow drain serves to safely discharge excess fuel. Fuel tanks are also equipped with a drain valve, often referred to as a sump drain or fuel strainer drain. This valve is typically located at the lowest point of the fuel tank. Performing a fuel sump check is a critical pre-flight procedure for pilots. By opening the drain valve and collecting a sample of fuel, pilots can visually inspect for the presence of water or contaminants. Regular sumping ensures the fuel supply remains clean. The fuel journey lines, shut-off valves, and primers. Fuel lines transport fuel from the tanks to the engine. These lines must be robust and capable of withstanding the pressures and temperatures associated with the fuel system. They are typically made from metal or flexible, reinforced hoses. A critical component in the fuel supply system is the fuel shut-off valve. This valve allows the pilot to stop the flow of fuel from the tanks to the engine. Its primary use is in emergency situations, such as an engine fire or a suspected major fuel leak. The primer system is another important part of the fuel supply system, particularly for piston-engine helicopters. Its purpose is to assist in starting the engine, especially in cold weather conditions. The primer injects a small quantity of raw fuel directly into the engine's cylinders or the intake manifold. Overpriming can lead to engine flooding or a fire hazard, so pilots must use the primer according to the manufacturer's recommendations. Section 5. Ensuring clean fuel, the critical fuel filter. The fuel filter plays an indispensable role in maintaining the health and reliability of the helicopter engine. Its primary function is to remove particulate contaminants and, in some designs, water from the fuel before it reaches sensitive engine components. Helicopter fuel systems typically incorporate one or more fuel filters. A main filter is usually located in the fuel line between the fuel tank and the engine. Some systems may also have a finer filter, sometimes called a last chance filter, located just before the fuel metering device. Regular inspection and replacement of the fuel filter element are critical maintenance tasks. The consequences of a blocked fuel filter can range from reduced engine performance to complete engine stoppage. The fuel filter is a silent guardian of the engine, and its importance cannot be overstated for maintaining reliable power. Section 6. Powering fuel flow, engine-driven and electrical pumps. Fuel pumps deliver fuel from the tanks to the engine. Helicopters use engine-driven and electrical boost pumps. The engine-driven pump is primary during flight. Boost pumps prime the system before start. They provide backup during critical phases. Both pumps ensure a reliable fuel supply. Pilots monitor fuel pressure and follow procedures. This dual pump system enhances safety and reliability. Section 7. Monitoring and managing fuel gauges and planning. The fuel quantity gauge is a critical instrument in the helicopter cockpit, providing the pilot with information about the amount of fuel remaining in the tanks. Accurate knowledge of fuel quantity is essential for safe flight operations. Several types of fuel quantity indicating systems are used, with float-type and capacitance-type gauges being common. Effective fuel planning is a cornerstone of aviation safety. Before every flight, pilots must calculate the amount of fuel required for the intended journey, including fuel for startup, taxi, climb, cruise, descent, and approach. Crucially, regulations and good airmanship dictate carrying reserve fuel. While fuel quantity gauges provide a continuous indication of fuel levels, they should not be the sole source of information. Pilots must always verify the fuel quantity before flight through other means if possible. Diligent fuel planning and verification are essential pilot responsibilities to prevent fuel exhaustion or starvation. Section 8. The engine fuel control system, precision metering. Once fuel is delivered from the supply system, the engine fuel control system takes over. This system's primary and critical role is to precisely meter the fuel and mix it with air in the correct proportions for efficient combustion within the engine. The engine requires different fuel-air mixtures depending on various factors, including the power setting selected by the pilot, engine speed, altitude, and ambient air temperature. The fuel control system must continuously adjust the fuel flow to maintain an optimal mixture. The reliability and accuracy of the engine fuel control system are paramount for flight safety. Any malfunction in this system can lead to significant engine performance issues. Regular maintenance and inspection of the fuel control components are essential to ensure they function correctly. This system truly dictates the engine's ability to perform. Section 9. Carburetor systems and the hazard of icing. Many piston-engine helicopters utilize a carburetor to mix fuel and air for combustion. The carburetor operates on the Venturi principle. As air flows through a narrowed section in the carburetor throat called the Venturi, its speed increases and its pressure decreases. This low pressure draws fuel from a float bowl through a discharge nozzle into the airstream. While relatively simple and cost-effective, carburetors have an inherent vulnerability. Carburetor icing. Carburetor ice can form when there is sufficient moisture in the air, and the temperature within the carburetor drops below freezing. The formation of carburetor ice restricts the flow of the fuel-air mixture to the engine. To combat carburetor ice, helicopters with carbureted engines are equipped with a carburetor heat system. This system directs heated air, usually ducted from around the engine exhaust manifold, into the carburetor intake. Pilots must be familiar with the proper use of carburetor heat as outlined in the aircraft flight manual. Section 10. Fuel injection systems and concluding thoughts on safety. As an alternative to carburetors, many modern piston engine helicopters and all turbine engines utilize fuel injection systems. Fuel injection delivers fuel directly into the engine's intake manifold near the cylinder intake ports, or in some advanced systems, directly into the combustion chambers. This method offers more precise control over fuel delivery compared to carburetors. Fuel injection systems offer several significant advantages over carburetors, including the elimination of carburetor icing. Other advantages include more uniform distribution of the fuel-air mixture to each cylinder, leading to smoother engine operation and improved fuel efficiency. Despite their advantages, fuel injection systems are generally more complex and can be more expensive than carburetor systems. In conclusion, the helicopter fuel system, encompassing both the fuel supply and engine fuel control components, is fundamental to every flight. A thorough understanding of these systems, diligent pre-flight inspections, careful fuel planning, and vigilant monitoring during flight are paramount responsibilities for every pilot. Knowledge and respect for the fuel system directly translate to safer skies.